is rationalize the denominator. And what they mean by that is they want us to get rid of the square roots from the bottom. That's right, it's easier like this, huh? All right, so they want us to get rid of the square roots from the bottom. So how do I get rid of that square root from the bottom? So that's what they mean by rationalize. Make the bottom, make the denominator not have any, when you're all done, make sure the bottom does not have any square roots. So how do I get rid of that square root from the denominator?
Multiply by 5.
Yeah. Multiply top and bottom by square root of 2. Now, why do we have to do top and bottom? Yeah, so we don't change anything, huh? It's a fraction. So, square root of 2 over square root of 2 is a fancy 1, isn't it? Right? That's the same thing over itself. That's a fancy 1. If you're multiplying by 1, you're not changing the value. You're just changing the way it looks, right? As long as you say thing top and bottom, you're not changing the value. You're just going to change the way it looks in the end. Okay. So now on the top, square root of 3 times square root of 2, square root of 6. On the bottom, square root of 2, square root of 2, square root of 4. Or, yeah, just plain 2 would be better, huh? Let's just do that. So it's the square root of 6 over 2, and we're done. What did we do? We got rid of the root from the bottom. Does that make sense what just happened? Remember how when you have 2 of the same square root, it ends up being one of those regular? Do you know what I mean? Let's make sure, because we're going to do a bunch of that today. Let's make sure that's still working for you. So if, say you have square root of 7 times square root of 7, what's that going to equal?
7.
Yeah, just plain 7, because it's square root of 49, which is plain 7, or because 2 7s inside, send 1 7 outside, huh? That's really the reason. It's the 2 in, 1 out thing, huh? So we'll do a bunch of that tonight. So that's basically what happened down below, right? We had two 2's inside, and that led to 1 2 outside. And what did we do? We got rid of the square root from the bottom. This answer here is actually exactly the same value as the original. Anybody have your calculator? What's the square root of 3 divided by square root of 2? Here, I got it also. I want to just show you that we haven't changed the value. Wait. I'm getting 1.2247. They're both 1.2247. Try it on your calculator. Try doing either one. You getting that? Square root. I'm talking about the original square root of 3 over square root of 2. Square root of 3 over square root of 2 and square root of 6 over regular 2 are both 1.2247, blah, 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 blah. Meaning, we didn't change the value, we just changed the way it looks. You don't have to find the decimal. They're not asking us for that. But I just wanted you to see that we haven't changed the value. It's the same value it always was. It just looks different now. It doesn't have a root on the bottom. And that's what they want us to do. That's what this section's all about. Seems so simple, huh? Get rid of all the roots from them. They're going to get more tricky, obviously, than this one. Is that making sense? Questions I can answer? Okay. So, same kind of thing. This whole lecture, this whole section, get rid of the roots from the bottom. So there is a square root over the entire fraction. So that means that the square root is on the top and on the bottom, huh? I think it's just easier just to write it out like that, just so we can see it super clear. That root that's over the entire fraction is on the top and the bottom. And now, can we square root the top, the square root of 1? We can, huh? What's the square root of 1?
1.
That's just 1. So you don't even need the square root in the bottom anymore. The square root of 1 is just 1, right? What times itself is 1? 1 times itself is 1. The square root of 1 is just 1. Now, we can't square root the bottom. I mean, it would be some ugly decimal, right? Square root of 5 we can't do. So we leave the root on the bottom. Y'all tracking with what I did so far? So the square root tries to root them both. It can root the top, and so it vanishes. When you square root something successfully, it then vanishes, doesn't it? So I square rooted the 1 on the top, and it just came out 1 and left. I tried to square root the bottom, but you can't square root 5. Now, I can't leave it this way because it still has a root on the bottom. I have to get rid of that root. So what's going to get rid of that root? Yeah, top and bottom by square root of 5. And so what does that equal? Square root of 5. And the bottom, 2 5s in, 1 5 out, huh? On the bottom, and we're done. What did we do? We got rid of the root from the bottom. Why can't I cancel those 5s?
Because they're not the same.
Different worlds, right? Insider, outsider. Insider, outsider. On that. Different worlds. They live in different worlds there. All right, let's keep going. Now, number 3 is going to be more tricky. 9 over the cube root of 5. Okay. So, number 3. Okay. So, that 3 is in the hook there. So, remember, it's a real important difference, right? Whether a number is in the hook or just in the front. So that number is actually in the hook. It's not a big 3 in the front. It's a tiny little 3 in the hook. And what does that mean? Cube root. And what does that mean we do as far as shipping things out of the root? It's a 3-for-1 deal, huh? You got to have 3 whatevers inside this root if you want to ship 1 out. And that's exactly what we want to do, don't we? That's the name of the game. We want to get rid of the root from the bottom. And the only way we're going to be able to get rid of that root from the bottom is if we can ship everything out. And the only way we're going to be able to ship everything out is if we have how many of them? 3. You see, that's different than like the last one. You see what's changing? This is a 3 shipper rather than a 2 shipper. Do you see the difference? Right? On this last problem, that's why I want to keep them both on the screen at the same time. On the last problem, there was nothing in the hook, which means 2, as we know. Which means if you have 2 5s inside, you can ship 1 out, right? It's a 2 shipper. 2-for-1 deal. But now we have 3 in the hook. So in other words, how many, I've got to make there be 3 5s in here if I want 1 to ship out and the root to go away from the bottom, which is what I want. I want no more root in the bottom. So if we need to have 3 5s down there, and we currently have 1 5, how many more do we need? 2 more 5s. Does that make sense? You've always got to make it match the hook number. What I mean is, you've got to make 3 5s so you can ship 1 out. If that had like a 4 in the hook, well, what if that had a little 4 in the hook? Then I would need 4 5s. So I would need to give it 3 more. Right? Getting the idea? What if we had like a 7 in the hook and we started with 2 already in there? How many more 5s would we need in order to ship 1 out? 5 more. So you get the idea. Whatever the hook number is, you got to make there be that many things in so you can ship 1 out. That's the name of the game.
Like that 5 is only 1, you can make it a fraction to bring them out?
Make it a fraction?
A fraction?
What you mean like swing it around? Where are you getting the fraction thing?
No. Okay, you need 3 5s to get 1 out, right?
Right.
You only have 1, so you got a third of a 5.
I do. That is 5 to the 1/3. But that won't help us in any way. What you say is true, but that's not how we need to think right now, even though that's a true statement. So what I'm going to need to do is give it how many more 5s? 2 more 5s. So I'm going to go 5, 5, or you can write 5 squared, either one, same thing. Make sense what I'm doing?
Oh, okay.
So it had 1 5. I'm giving it 2 more. Of course, you got to do the same thing top and bottom, keep the balance, right? Giving it 2 more. So how many all together on the bottom now? 3 in, which will make 1 out, huh? That'll get rid of the root. What's the bottom going to be? Just 1 plain 5, huh? Because these 3 5s in will ship 1 5 out. You tracking with me? And then what happens on the top? Can that 9 multiply those 5s? No, he's an outsider. And they just stay inside. They just make 25 and we're done. That's it. What did we do? We got rid of the root from the bottom. How are we doing? What's that?
We don't care about the square root.
Right, we're fine with the roots on the top. They just don't want roots in the bottom. Exactly. They're fine with the roots in the top, just don't want them in the bottom. Exactly right. Does that make sense? So in these problems, you're always looking at the denominator, saying how many 5s does he have? 1. Okay, give him 2 more. Then he'll have 3, and he can ship 1 out, and there's no more root in the bottom. That's how we get rid of the root. And whenever we do the bottom, we have no choice. Same thing on the top. And why can't I go 5 into 25?
Because it's different.
Different worlds, right? Outside the root, inside the root, no interacting. All right. Let's try one like that. Assist you with this one with a little bit. Okay. So, and what's in the hook? 3. So which means you've got to make there be 3 of everything inside to ship out and get rid of the root, which is the name of the game. Get rid of that root from the bottom. Okay. Well, right now, right now, I would say I'd break that 9 down. Go, hey, that 9's 2 3s, isn't it? So or just think it. You don't even need to write it. If you want to just think it, that's fine. Just know that right now, inside that root is 2 3s and 2 x's. So right now, there's 2 3s, 2 x's. Remember, you need to make there be 3 of everything for it to ship out and the root go away. So how many more 3s do we need to give it?
1.
And how many more x's?
1 x.
Exactly. So we're going to multiply by root 3x. But yeah, don't forget to keep the little 3 in the hook. That's exactly right. Like that. Is that good? It's got 2 3s and 2 x's. I give it 1 more 3 and 1 more x. Same thing top and bottom. So what happens on the bottom? Just 3x. No more root, right? Because the 1, 2, 3 3s in sent 1 3 out, and the 1, 2, 3 x's in sent 1 x out. Huh? What do you do on the top? Just smush it together. There's never anything going on the top. 7 cube root 3x done. How are we doing? Is that good? Questions I can answer? We got rid of the root for the bottom. All right, let's backtrack to number 4. Go back to number 4. So, number 4, what's in the hook on number 4?
2.
And nothing 2. So that means it's a 2 root. So what you always want to do is first take inventory of before you don't do this. Don't right away put another 8x. Just look at what you've got. What's in an 8?
3 2s.
2 4 2 2. Yeah, so 3 2s. So really what we have in there right now is 3 2s and an x. Huh? Now, what does he ship out? What's in the hook? 2. In other words, we can make 1 shipment right now. Do that right now. Whenever, if you've got stuff already in there that can ship out, do that first because that makes things easier. So I'll take like these 2 2s and I'll ship 1 out right now. What's left inside?
1 2.
1 2 and the x still, huh? 2x. We good so far? So everybody catch up because that'll sometimes if you don't do that, the problems get really ugly. So you want to always do that first. So first, do any shipping out that you can. I'll show you as we go. But it'd be good if you wrote a note for yourself. So first, ship out anything you can. So if there's something that can already ship out, do that first before you multiply top and bottom. Anyway, we did it. We're good. But now we still have to get rid of that root from the bottom, don't we? So what's in the hook?
1 2.
2. And so we got to make there be 2. We're back to the 2 thing. 2 of everything. So we have a single 2 and a single x.
Multiply by 2x.
So multiply by root 2x, huh? Top and bottom. So what happens on the bottom? So we have that. Now don't forget there's stuff in the front. And so this 2 right here. He's in front. Right? He's right there. And then what does root 2x make? 2x. Yes, so it's going to be 4x on the bottom eventually, huh? Everybody see that? And yeah, so that I'll finish the denominator. It's going to be 4x totally. And then what do you do on the top? Just smush them together. Nothing fancy. Just 7 times root 2x. That's the top.
Okay, 2x and 2x.
And we're done.
They combine and make them 2x, and then you multiply by 2.
Everybody see that? So these two 2x's inside sent 1 2x outside, multiplying the 2 that was already outside. 2 times 2 is 4x. Yeah.
So you never move the whole thing on the bottom right, the denominator, you just do whatever is in the root.
Say that again?
So we don't multiply the 2, getting the square root 2x on top and bottom. Just the square root 2x.
So I
the 2 and the 2x.
So I don't multiply 2x and 2x?
No, the 2.
This 2 out here?
It stays there all the time.
It doesn't go in. You mean? It just stays there until this stuff comes out, and then it multiplies. Am I answering your question?
It's cool.
So it did multiply eventually, but it can't multiply stuff inside
I don't know what this comes
until that inside stuff comes out. That makes sense? So yeah, so the rule is outside stuff with outside stuff, inside stuff with inside stuff. So when that inside comes out, then they multiply.
So they're not like a package.
Yeah.
Right, they're not glued, are they? There's no pluses or minuses, huh? Right, because the packaging is the pluses and minuses. Yeah, so it's not that. We're going to get that in just a minute, though. And that'll change the game a little bit. Yeah, this is not. That's what you're hoping for, right? You're like, I want the packages.
Yeah, that's exactly.
Yeah, right. I could read your mind, yeah. Yeah, so there are no packages here exactly, which makes it fairly easy and not too messy. Good. All right. That one. What's in the hook there? 3. So he's a 3 shipper, right? What's already in his root? 2 2's. Yeah, visualize that as 2 2's. And he's saying, give me 3 of anything, and I'll ship 1 out for you. Right?
To make a square root of 2.
So what do we got to give him?
Cubic root.
It turns it by 2.
Right, huh? So that gives us
1 more 2, right?
3.
Square root of 2. Cube root of 2. Oh, cube root of 2. I mean, cube 2. Yeah.
You give 6, no?
So cube root 2, top and bottom. Is that good? So on the bottom then, we have, this is really 2 2's.
We have only
And a third one.
6.
So just a 2 on the bottom.
Those combine.
On the top, they just crunch together. 3 cube root 2, done. We good? Got rid of the root on the bottom.
3.
Questions? All right. Let's see. I can't even read that. Okay, so when we have a square root, top and bottom. Whoops. I'll go ahead and put that on the top and bottom.
6 squared. 3.
And then that 12, let's take inventory on the 12 right now. That's 4 times 3, 2 times 2. Good. So then that's root 7x. The bottom is 3 times 2 times 2. Any order you want to put those in. Good so far? What's in the hook? 2. So he says, if you see 2 of anything in here, ship 1 out, right? 2 for 1 deal. That's what they're always doing, right? Whatever's in their hook is like the director. There's nothing in the hook, which is 2 for 1. So 2 2's in. 1 2 out. They're both gone, right? So 2 for 1. 2 for 1. Just 1 2 comes out, representing them both. It's a 2 for 1 deal, like at the store. Things are on sale 2 for 1. You pay for 1, but you walk out with 2, right? 2 have left the store, but you paid for 1. 2 for 1 deal, right? So what does that give me? Root 7x over 2 root 3. So far, we still have to get rid of that root from the bottom, but there's the first ship out move. We good there so far? Now, how are we going to get that final one? No more root at all in the bottom, huh? So we got to get rid of that 3. How many 3s do we need to ship out of there? 1 more 3, because you're going to have 2 total, huh? Because that's a 2 in the hook. So give it 1 more 3, top and bottom. But see how I first shipped out what was already there? Before you bring new stuff in, first ship out what's already there. See how I did that? So now, now just root 3 over root 3. Is that good? And then we'll have, now be really clear what's in the bottom. There's a 2 already out. He's still there. He's not going to vanish. Times, he's multiplying. He's not adding or anything, right? Times. The 2 3's in. 1 3 out. It's going to be 6, isn't it? They're outsiders now. They'll just multiply 6. On the top, you just smush it together. So 7x and 3, they're both insiders. So they just multiply root 21x. All inside. They were just both inside. Nobody's coming out. There's not 2 of anything up there, right? So it's root 21x over 6. We're done. Is that good? Questions I can answer? How are we doing? How many got that? Let's just want to see. Speed up, slow down, about half, okay? Any questions I can answer on that?
So when you have, like, let's say the 2 outside, and you got the other 2 roots, you just multiply the root, but you don't
do the 2. Yeah, well said. Well, exactly. Yeah, you don't do the 2. You just do the root. Exactly. Because I don't have a problem with the 2. Remember what our issue is. We don't like the roots in the bottom. We're fine with the 2. Okay. We're not okay with the root. And so what will get rid of that root? Another root, because 2 in, 1 out. Yeah, but I don't care about the 2. The 2's fine for the moment. In about, well, probably in like just a couple minutes.
Oh.
All of a sudden, they're going to put a plus sign in the middle there. Or a minus sign. And what does a plus or minus do between 2 things? Then they'll be stuck together, and I'll have to use the 2. So what you're saying will be required in just a minute. Right now, I don't have to. They're not glued. That 2, they're just times, which is separate. That's shopping at whatever, Save Mart or whatever. You don't need to buy. They're not glued, right? But in a second, they're going to stick a plus or minus, and then they're stuck, and I'm stuck using the whole thing. Actually, we'll put the opposite sign in the middle. It's a special trick, which we'll do in just a minute. But yeah, for now, just the root. Just the root. Okay. Number 12, 1 over root 45. I'll just make that an x. 12. Okay, 1 over root 45x. Want to try that one? All right, so break down that 45. What's already in there? 5 times 9, 3 times 3. All right, so it might be helpful to rewrite it, so I'll do that. Square root of 5 times 3 times 3 times x. Okay, so what can ship out right now? Yeah, because what's in the hook? 2, nothing, 2. So 2 3's in, 1 3 out, they're gone. Getting the idea on the ship out? 2 3's in, 1 3 out, they're gone. So we get 3 root 5x like that. Good so far? Now, I can't leave that root in the denominator. He says, well, I can ship them out if you'll give me 2 of everything. Right? Give me 2 of everything, because there's nothing in his hook. That 3 is a big 3 in the front. It's not in the hook, right? So there's a 2 in the hook, invisible 2 in the hook. And it's saying, give me 2 of everything, and I'll get rid of the root for you. I'll ship everything out. That's the shipping requirement, isn't it? So you got to multiply by root 5x, root 5, because that'll put 2 5x's in roots, which will ship 1 out. That's the fundamental idea, right? 2 in, 1 out. So what do we have left then? On the bottom, we're that 3 that's already been shipped out. He's still there, don't lose him. Times the 5x that is newly shipped out. The roots are gone. When you ship everything out of the root, it vanishes, right? Right, this 5x and this 5x shipped out 5x. On the top, you just crunch these together. 1 times root 5x. You don't even need the 1 there. So it's just root 5x over 15x, isn't it? Is that good? Why can't I cancel the x's or the 5 with 15? Different worlds. In the jail, out of the jail. No interaction.
That's a good analogy.
What's that?
That's a good analogy.
Yes. I a long time ago.
You gotta watch out Friday or Saturday.
Loved it. I'm a fan now. I must admit. So funny. All right. All right. So what's under that root? So here we are again. Now what's in the hook here? 3. It's a 3 shipper. It's a 3 shipper. So there's stuff already under there. What's already under there? 2 5s and 2 x's. And remember, he's a 3 shipper. So he's saying, give me 3 of everything, and I'll ship them out for you, and there'll be nothing left under the hook.
We need a root of
No, under the root.
5x.
So yeah, so how much more stuff do we have to give him?
1 5.
1 5 and 1 x. Yeah, so go ahead. And same thing top and bottom, right? All right, so... Okay, and make sure the 3 stays in the hook. 1 more 5, 1 more x. Same thing top and bottom, right? Good. So what's coming out on the bottom altogether?
5x.
Yeah, just 5 and x. Because we have 1, 2, 3 5s. Ships out 1 5, and same thing for the x's, huh? We good there? What do you do on the top? Just smush them together. Don't even worry about it. They're all insiders. They're all in the prison. Just let them multiply together, right? It's cube root of 5 times 7, 35, xy squared. That's it. Nothing more to do. Is that good? Because there's not 3 of anything up there. Nobody's coming out of the prison on the top, right? Good? This making sense? What did we accomplish? Got rid of the root from the bottom. Okay, right away, break down that 256. So what's that? 2, is it times 128? Yeah, it is. So there's going to be a bunch of 2's here. 2 times 64, 8 times 8. And you know 8 is 3 2's. 3 2's. Look at all those 2's. There's a whole whopping bunch of 2's there. So let's rewrite this thing. This is the 4th root, so that 256 in the top has become, how many 2's is that? It looks like 8 2's. Right, don't forget the 2 over here. 6 on the bottom, 2 on the side, 8 2's all together. Right, you with me? 8 2's all together on the top. And then the bottom is, what is 9? 2 3's, and then x cubed is 3 x's, as you know. You don't have to write it that way. You can just leave it x cubed if you want. I'm just trying to be extra clear. So now, what's going to ship out of the top?
2 2.
Yeah, 2.
He's a 4 shipper, right? He's saying, give me 4 of anything, and out they go.
2 top.
I mean, 2.
Yeah, so 4 2's right there. We'll ship out a 2. And 4 2's right there. We'll ship out another 2. So 4. Huh? And there's no more root on the top, is there? Because there was nothing left over in the root. Getting the hang of that? That's when a root vanishes, huh? When there's nothing left over in it. On the bottom, in fact, I'm just going to bring it down because there's nothing fancy. So on the bottom, it just stays as it is. There's nothing that can come out of the bottom yet. Now, we have to get rid of the root from the bottom. How do we do it? So remember the bottom, so we got the top cleaned up on its own real nicely. Everything shipped out, no more root on the top. Now on the bottom, he's saying, I'm a 4 shipper.
We need 2 3's and an x.
Yeah. He's saying, so make sure there's 4 of everything in here, and I'll ship them all out. So give him what he needs, so there'll be 4 of everything, 2 more 3s, and an X. Huh? Same thing, top and bottom. So that'll be 4th root of 2 more 3s and an X. 2 more 3s and an X. And so what comes out on the bottom then? Just 3 and X, huh? Because those 4 3s ship out 1 3, and those 4 X's ship out 1 X. On the bottom, you with me? 4 3s all together ship out 1 3, and 4 X's ship out 1 X. Now what happens on the top? Just crunch it together. Doesn't matter. But keep outsiders outside, though, and insiders inside. So that this 4 is an outsider. And that's 4th root of 9x. Just make that 9x, and we're done with that one. Is that good? Got rid of the root from the bottom? Questions on that one? All right, so here we go. So now we know this one's going to be harder because those are glued together on the bottom. We're not going to be able to handle this one by just multiplying top and bottom by root 3. It's not that simple. You have to use the entire package, the whole 1 minus root 3, but you have to change the sign in the middle. It's a special process. It's even got a name. It's so special and commonly used. So let me write it out for you. So when you have a root and a plus or minus in the denominator. So this is a special situation. They're going to give us like 3 or 4 of these. A square root and a plus or minus in the denominator. You multiply top and bottom by the same as the denominator, but opposite sign in the middle. In other words, if the middle starts with a minus, we'll use a plus. So notice I'm going to multiply top and bottom by 1 plus root 3. See how I used exactly the denominator but changed the sign in the middle? Is that making sense? That goes by the name conjugate. I'm not going to quiz you on the name or anything, but if you ever need to refer to that, I don't really know when you would. But that's what it is. Well, if you're going to higher math, they will go to trade, pre-calc, going that way.
What's the word?
Conjugate. Conjugate. Yeah, they'll use that word if you go to pre-calc. If you go to stats, you'll never see it again.
You can use that in physics either.
But conjugate, if you're going the way of pre-calc and calculus and trig.
Totally means totally different.
So conjugate.
Inside.
All right, so does that make sense? When do we do this? What's different all of a sudden? How do we know we're supposed to suddenly? Because that's a lot of the battle on a math test, isn't it? You know, we learn all these different things. It's hard to keep them straight and know when to do them. How will you know on the exam in 2 weeks on this material? How will you know when you're supposed to do this whole fancy conjugate thing?
To cancel the...
When you see a plus or minus.
The root and the plus or minus.
Root and plus.
That's what's different between this one and, say, the last one, right? See, the last one, here, we had square roots, but there's no plus or minus down there, right? Or even right here. We had square roots, but there's no plus or minus. Right here, square roots, no plus or minus. But now all of a sudden, we have a square root and a plus or minus. All right, so let's do it. So what are we going to do? It's basically going to be a bunch of multiplication. So I'm going to take this 6, and I'm going to multiply both those. So that 6 is going to multiply both of those. Remember the rule, outsiders with outsiders, insiders with insiders. So 6 times 1 is 6, and then 6 root 3. There's the top. Good so far. See how that 6 stayed outside? He didn't multiply the 3 because they're different words. So I just distributed the 6 to the 1 and the square root. Good there? Now on the bottom, we're going to FOIL, huh? First to both. Because these guys are separated. You with me? These guys are separate. Although glued, but still they're separate. Like at Costco, those are two items that are glued together. So there are two things. So that's FOIL. That's first to both, second to both. They're going to take their turns, aren't they? Right? You with me? So this one is going to go first. First goes to visit both. It's all multiplication. 1 times 1 is 1. Plus 1 times root 3 is just 1 root 3. That 1 stays outside. The 3 stays inside. Separate worlds. Done. And now it's the negative root 3's turn. He's going to visit both of the 2 in the other parenthesis. So negative 1 root 3. Again, the 1 stays outside. The 3 stays inside. And last one, what is negative root 3 times positive root 3? First off, what's the sign? Negative times positive? Negative. And what's 2 root 3's? 1 plain 3, right? Out it ships. Right? That's the shipping requirement, right? 2 3's. Or you can make it root 9 if you want to, but that's still going to just be plain 3, isn't it? Tracking with me? Now, why are we doing this again? We're trying to get rid of the root from the bottom. Did we?
Yeah.
Because, see what's going to happen?
They cancel each other.
Do you see why we use the opposite sign now? Because that gave us 1 plus and 1 minus, which got rid of the root. That's why with the conjugate, you use the opposite sign. Because it does this. There's a reason. So that'll happen every time. Every time you've got this root with plus or minus, and you multiply top and bottom by the same as the denominator opposite sign, you'll be 1 plus 1 minus on the roots. So what are we left with then? 6 plus 6 root 3 over 1 minus 3. Now, there's a couple more steps here, actually, which can really trick people. It'd be a bummer to get this far and get tricked, but there's a couple tricks left. Are we good to hear, though? Good so far? Can I add these 6's on the top?
No.
No, because they're unlike terms. It's like 6 plus 6x or something, right? If this had a root 3, then I could add it. If it was 6 root 3, it's 6 root 3, it'd be 12 root 3. But he doesn't have a root, he does. Those are unlike, they must stay. But on the bottom, I can subtract those. They're just plain numbers. Right? So the top I cannot do. Remember when you got to have like roots to add, and they're not. The bottom is negative 2. Right? Okay, so what? Well, now I can put that negative 2. It goes into both those 6's, doesn't it? So I'll just put 6 over negative 2 plus 6 root 3 over negative 2. See how that negative 2 goes underneath each one? Right? He already is. It's one big bar. He's underneath the whole thing. So he goes underneath each one. And then you just divide them. What is 6 divided by negative 2?
Negative 3.
Negative 3. And what is, again, 6 divided by negative 2 is negative 3, and the root 3 is still there. There it is.
Calculator works on this one.
Is that good?
Because it has no variable.
Say it again.
So they give you the
What did you say? Subtract these two or something? Yeah, because again, they're unlike. They're unlike. Because this is like an x. Remember, roots are like x's. So this is like minus 3x. And they're unlike terms. Yeah, this one has a root, this one doesn't. They're unlike terms. They just stay separate. What did we do? We got rid of the root from the bottom. Try one of those questions on this one before we try one?
Can you go over how you did that second part of that?
What part? Where I put them both over the negative 2?
Yeah.
Yeah, so I literally just did that. See how that bar was all the way across? So that means they were both really over that negative 2. So I just separately put them both over the negative.
And then you just got rid of it.
And then I just divided. 6 divided by 2. 6 divided by 2. Yeah. And yeah, the root, he's in a different world, right? He's an insider, so yeah. He was just watching them divide. All right, let's try one of these. So let's try that one. So how would you know you have to do this? this whole fancy thing? What's telling you you've got to do it?
The minus.
The square root and the minus, right? So what are we going to multiply top and bottom by? Yeah, exactly the denominator, but opposite sign in the middle, and then put parentheses, distribute the top, FOIL the bottom, away. So here we go. So this minus 4 is going to go to both. Outside stays outside, inside stays inside. So minus 4 root x minus 12. Question?
The 3's not under the root.
Right, so those 3's are not under the roots. Yeah, so that's a good question. Yeah, did everybody notice? The root is only on the x on the bottom, not on the 3. And that matters. It would be different if it went all the way. The only guy under the root is the x. So see, I multiplied by the conjugate. The same as the denominator, but opposite sign in the middle. When do you do that? When you got a Costco package on the bottom with a root. Right? A root with a plus or minus. They're glued. So you have to use them both. You can't just do the root like we did on the other ones. Right? You tracking? Well, I better keep going. All right, so on the bottom, boom and boom. Right? Because it's two separate things. They're glued, but they're still separate, and they're going to first to both. The first one will go to the both, and second to both. So what's root x, root x? Plain x, right? 2x's in, 1x out. That's the name of the game today, right? Plus 3 root x. He's done. And now this minus 3, it's his turn to visit the 2 in the other parenthesis. Boom, boom. Minus 3 root x. And minus 3 times 3? Minus 9. Look what happens in the middle. If you want to save time. But I know you guys got nothing but time, right? You know, this is always going to happen. And you could just skip the O and the I in the middle. You know what FOIL is? I don't usually talk much about FOIL. First, outer, inner, last. I don't know if you've seen that before. Basically, it's always, whenever you're doing the conjugate thing, the middle 2 are always going to cancel. That's the very design of the conjugate. If you want to save time, the middle 2, the O and the I, are always going to cancel. It's always going to end up just being the fronts, and the front times the front, which is what F stands for, and the last times the last. Right? Front times front, last times last. The middle stuff will always cancel when you're doing the conjugate. Not like always, always, but always when you're doing the conjugate. If you want to save time. So what do we got left? Minus 12 over x minus 9, right? Can we do anything more there? Root x, root x. 2x is in, 1x out. We good there? Other questions on that one? Yeah, there's nothing more on that one, huh? We're done. We can't cancel any of that stuff because those are all packages, top and bottom, you know. No, that's it. We're done. What did we do? We got rid of the root from the bottom. Good. I want to try maybe 2 more of these if we can. You okay with that one? Questions I can answer? Everybody see how that FOIL worked on the bottom? Everybody see like what Erica was talking about? The square root times the square root? Square root x made plain x. 2x is in, 1x out. Let's try this one. How would you know on the test, this is on the test, you're going to have to do the whole conjugate thing? What tells you you're going to have to do that whole thing? The square root along with the plus or minus in the denominator. They're glued together. It's a package deal, which means you need to multiply by the entire denominator, but opposite sign in the middle. And you got to FOIL the top and FOIL the bottom. Now that's a messy FOIL. Why don't we do it one step at a time? So go ahead. Right. I forgot. There was supposed to be a square root on that 10, huh? I just messed it up. Thanks for pointing that out. Yeah, there we go. Now it's the same as the denominator. The denominator had a root on the 10, huh? So yeah, it's got to be the same as the denominator, opposite sign. Yeah, thank you. Now it's correct. So it's got to be exactly the same as the denominator, opposite sign in the middle. Okay, I'm going to do it. So this 2 root 2 is going to go boom and boom, right? Right? That's the first to both. And when he goes, outside with outside, inside with inside, right? So here we go. The 2 and the 4, 2 times 4, 8, and the inside 2 with the inside 2, root 4. Which really is going to become plane 2 times 8 is 16. If you want to just make it 16 now, great. I'll wait. But do you see what I'm talking about? That root 4 is now, what is the square root of 4? 2. This is really 8 times 2. It's going to be 16. You can do it now or later. But I'll wait. I don't want to do too much if you want to confuse. You see what happens so far? This is my first step. Outsider times outsider, insider times insider, right? That's just the first of my 4 multiplications on the top. Plus, and now the 2 root 2's go into the root 10. 2 root 20. Right? That inside 2 with the inside 10?
No.
He's done. He's gone to both of the other 2. That okay? And now, this root 10 is going to go boom and boom. So outside with outside, inside with inside. Plus 4 root 20. Right? Insider with insider. Plus, and what's root 10? Root 10? Plane 10. You can make a root 100 if you want, but what is the root of 100? 10. Either way, same thing. The top is done. I mean, for now. There's more work to do there. But does that make sense how I carried out that FOIL on the top? Can you do the same thing on the bottom now? No? Yeah. Can you do the same thing on the bottom? First to bow, second to bow on the bottom. So here we go. 4 root 2. So boom, boom. It's going to be 16 root 4 plus 4 root 20. He's done. Everybody see what happened for the first 2? Now, 4 root 2 went boom, boom. And outsiders hit outsiders, insiders hit insiders. Right? 4 times 4 is 16. 2 times 2 is 4. Inside. And then the 4 and the 2 times 10 make 20 inside. We're going to have to simplify those all, and we're racing the clock here. But that 20 is going to have to break down. So is the one on the top.
Okay.
Right? Because there's going to be 2 2's in there. They're going to come out in a minute. And now, it's the mind. Now remember to take his baby with him. That negative in front of him is his baby. Take that with you wherever you go. It's going to go boom and boom. So this would be minus 4 root 20. Right? Insider with insider. And right there. Root 10, root 10? Plane 10. Oh, actually, look what happens in the middle. I forgot. What always happens in the middle? See, that's why you can actually skip the 2 middle ones if you want. Just do front with front and last with last. On the bottom, it'll always happen that way. If you want to just save some time. On the bottom of a conjugate, it'll always end up being just front with front and last with last. Anyway, so where are we at? We've got to keep going here. We're running the clock here. So what's the square root of 4? So I'm going to do a new line here. That's going to be 8 times 2. And then that 20... Yeah, that 20, I'm kind of running out of room. Oh, I can add these. These are like terms, aren't they? 2 roots of 20 and 4 roots of 20. That's 6 roots of 20. Plus 10. We actually have a lot of simplification to do on the top here. Everybody see what happened up there?
No, how did you get 6?
So the square root of 4 is just, yeah, if I can, I'm going to save some time. That's a 2 right there, and I'm just going to make that 16. That okay? That's just 16, right? And then the roots are like roots. Remember like roots? Same roots, they add. It's like 2 root 20 and 4 root 20 makes 6 root 20. Remember you add the numbers in front when the root parts match? Like roots?
Like roots.
Is that good for the top? And then on the bottom, what's that? 16 root 4. What's the root of 4? 2. So that's 16 times 2. 32 minus 10. Good so far? See what happened there?
And then the 20 we break down again.
Yeah. Right now, 16 and 10? 20. Those are just plain old numbers. They'll add. Plus 6 root 20. In the bottom, 32 minus 10? 22. But that root 20, I can clean it up. This problem just keeps going and going. Yeah, it is. Yeah, how about can I do that right here? I'm just kind of running out of room here. That root 20, remember what, let me bring it up here. Remember what the square root of 20 is? That's 4 times 5, and that's 225. So the 2 2's send a 2 out. So this is 2 square root of 5, isn't it? That root 20 is 2 square root of 5. Right? The 2 2's in there. Send a 2 out. So 6 times 2 root 5 is 12 root 5. We have one more step, if you can believe it. Are we good? This is what I was talking to you about earlier. Everybody good to there? Does that make sense what just happened? That root 20 is 2 root 5. So we're just always shipping 2 for 1 out, aren't we? This is the hardest one. This is the hardest one in the homework. So the 20, 225, a 2 ships out, 5 left inside. Outsiders multiply, 12 root 5. Okay, there's one more step. Everybody alert, I know we're running over time here. Let me just say this. Can I divide 2, say, out of these 2?
Yeah.
Well, not unless you do all 3. And you can, and you must. All 3, notice, because this is glue. This is glue. This says, I'm Costco. You buy them both, or you buy nothing, right? But we can do it. All 2 goes into all 3 of those, doesn't it? If all 3 outside the root, we're not talking about numbers inside the root. We're not going there. That's a different world. But the 3 outsiders that are out of the jail, the 3 outsiders, they're all divisible by 2, then you do it. If they can all be divided by 2, divide by 2, divide by 2, divide by 2. This would be 13, 6, and 11. So the answer is 13 plus 6 root 5 all over 11. It's finally done. Do you see what happened on that last step? If any of those 3 could not divide, then you're just done right here. Like if this was something like an 11 here, which is not divisible by 2, then you just stop. That's your final answer. If all 3 can be divided by the same number, if all 3 outsiders can be divided by the same number, then you do it.
You can't add the 26 plus the 12?
No, these are unlike roots. These are unlike roots. They can't add. He doesn't have a root 5. He was 13 root 5 and 6 root 5 they could add. All right, just this section and the quiz.